Hello friends, this is Vahid from VRF Education and welcome to my channel. In the previous episode, we talked about TDD with Qt in general, and we checked the concept, the cycle of TDD and things like that. And we also set up our first test project and wrote some basic tests. Now in episode 2, we are going to focus on the most important part of testing in Qt, the assertion macros. We will look at how to check conditions with QVERIFY macro and compare the actual and expected values with QCOMPARE. So there's a little bit difference between these two. We just get familiar with the QCOMPARE in the previous episode, and today we are going to check how we can use QVERIFY and also another variation of it named QVERIFY 2. And also we are going to know how we can deal with the known issues using QEXPECT FAIL and even force test to fail with QFAIL. What does this two mean? Sometimes there's an error with some test cases and we are aware of that, but we don't want the whole process to be failed. So we're going to tag them with QEXPECT FAIL and then continue the process. So this is very good for our CI integration. And by the end of this episode, you will know how to write meaningful test cases and understand the output of Qt gives you when you test, pass, or fail. So let's jump into Qt Creator and continue our journey. Okay, let's see what we did in previous session and what we developed. We created a simple Qt core application that contains two different parts or two different modules. One is the business logic of our project, TDD episode 1 introduction that contains the main.cpp or the main entry of our executable file, and nothing special is here. So we created another class named calculator and we want to write the test for this class. So we created another module here named test calculator, and we will see it inside the CMake file. And here we have a class. This class is designated for testing the calculator class, and we have this calculator class in both modules. So I just add them as a part of this module declaration. So we talked about this. That's our test class should be inherited from QObject class. We need to use QObject macro to be able to use slots. And here we are going to create a couple of different slots, private slots, for handling test cases, different test cases, and take into consideration that make them very specific. One method for one functionality. Do not combine the functionalities together. And then inside it, we do some operations, and using another macro named QCompare, we're going to check the result of a method call on calculator and compare it to an expected result. There's also another ways to handle this part, and we will talk about it in this session. And finally, we need to provide the main entry for this module. So QTest underline main, and then pass it the instance, the name of the class, the test class to this macro will let us to run this test separately from the application. And then at the last line, because we are not going to separate these QTest into two files, .h and .cpp file, we need to include to the mock file that created automatically by the compiler. And this is the whole thing that we created in previous session. Let's take a look at this file. So here, they added the test inside the package. We need to add this test package to be able to work with test in Qt. And then here I created another executable part named test calculator and just add test calculator cpp and also calculator cpp to this file, and create an executable for that. The name again is test calculator. For this test calculator, I'm going to use Qt core and Qt test modules. And nothing more. It's okay. These are the changes we need to apply to our CMake file to be able to work with QTest framework. So let's see what we can do here. Well, the next thing I want to talk about is the way that we can compare the results of the test. Here we use QCompare to compare the result of a method code with another value. So here we can use compare for equality. But what if we want to use another some other general purpose conditions like greater than, less than, or things like that? So in these scenarios, we can use QVERIFY. I'm gonna create another test. For example, I'm gonna call it test positive number. Imagine I'm gonna focus on an operation that the result should be positive. For example, we need to handle the result of generating some random numbers, and it needs to be positive all of the time. So I'm not gonna use calculator. Here I'm gonna use int value equal to 10, for example, and QVERIFY. It says, okay, pass me the expression. So I'm going to say value greater than 10. I'm sorry, greater than 0. And it should return true. Let's run the test by right-clicking on this module and click run. Okay, go. Here, as you can see, test positive also passed, so we have 4 passed tests. Now, if I change it to something like this, I'm looking for negative numbers, for example. This time the test will be failed. So as you can see, test positive number, value less than 0, return false. So here we have one failed test. Now we can check why this happens and how to resolve it. So I'm going to change it back to greater than. And also we can check the equality also with QVERIFY. And this is somehow act as an alternative for QCompare. Imagine that we are going to add subtract to calculator.h. So I'm going to create another method named sub, and it again receives 2 int parameters. And let's also implement it inside the calculator. It doesn't have any body, so we should be inside the ready state. I'm going to say void test sub, and this time I'm going to use a QVERIFY instead of QCompare. So I'm going to say QVERIFY and a statement. Let's also make an instance of calculator, calc.subtract. For example, 10 and 4, it should be equal to 6. This is the way that we can pass an what's happened? An statement instead of 2 different parameters, actual value and target value. We pass an expression here. So let's see what should be happen. So as you can see again, we have what? Test positive, test addition, and the app crashed. Let's see what's going on here. Inside the sub method, oh, we forgot to return something. Return 0 by default. Run the application. So we can also get the crash. So here test sub, calc sub, return false. So again, we are in the ready state, so we need to add minimal code a minus b to move to green state 1. I minus b, not 10. Because we failed, and we're going to check it again. So here, all the tests passed. So right now we are inside the green state, and that's because we use these 3 test methods to test our functionalities inside the calculator class. There's also another micro named QVERIFY2. By using QVERIFY2, we can pass a message to make our test result much cleaner. For example, here I'm going to change it again to less than 0. And if I run the test as we did before, one test will be failed. Let's see what we have here. Come on. So this time it says value less than 0, return false. So it's not very readable. So I'm going to provide, I'm going to use this QVERIFY2 and pass another prompt here, or maybe the value, oops, change the Persian, why? Value must be greater than 0. It's just a message that will be appear as a test result if test failed. So again, as you can see, value must be greater than 0. We provide a message for the developers or the one who run the test to know what's going on here and how to solve the problem. So as a rule of thumb, again, we will use QCompare when we want to check for equality, and we use QVERIFY or QVERIFY2 for more general purpose statement when we have a statement, not just the equality. Although we can use QVERIFY and QVERIFY2 for equality also, but we are going to use QCompare for equality and QVERIFY for general purpose conditions. So let's move on to the next macros that we have for testing. The next item I'm going to talk about is to test asynchronous actions or operations. In asynchronous operations, we need to wait a couple of seconds maybe, and then the result will be ready. Then we can check the result with the goal or the target values. Imagine we have a lengthy operation inside the calculator. Just imagine. So I'm gonna create a slot for this one. Test delayed operation. For this purpose, we use qtry_verify, this one, and then let's also create an instance of calc. And let's move to this class. I'm going to create bool do delayed operation. So by default, I'm going to return false. We are in the ready state right now, so qtry_verify, and I'm going to say calc dot do delay operation. So we don't need to send anything because the result of this method call is a boolean. It's like a comparison statement. So let's run this one. We are inside ready state, and by default it will wait until 5 seconds and continuously. So here we have which one? No, this one. Let's also make this one green. Run the test once again. And this is the beauty of test-driven development. Come on. So, as you can see, it will wait for 5 seconds. Wait. So after 5 seconds, it says test delay, return false, and it continuously check the result of this method. okay, this method call. So after 5 seconds, it says, okay, it's not gonna provide the expected or the true. It's not gonna evaluate this to true. So let's get in here. And if I just return this to true, we will get into green state very fast. There's no asynchronous operation there. So you can see 6 operation paths. So I'm gonna use a for operation. I'm gonna say return true, and then I'm gonna use this for loop of total 3, and I'm gonna say let's bring also. It's not a good approach, but I'm gonna use this one, Q thread. Oops, Q thread, and I'm gonna say Q thread dot sleep. Wait for 1000 milliseconds. So after 3 seconds, we will pass the code. And this is the refactor phase of our code. So run the application, and it will wait for 3 seconds. 1, 2, 3. Oh. So here, after 3 seconds, because we return true, all the tests passed. But here, if after, let me also change it to 1 second. See, there's any change inside the execution time. Well, it returned much faster. So using this QTry-verify, we can continuously check for asynchronous operations. And then if the result is true after in this 5 second period of time, then the test passed. Otherwise, the test will be failed. And what if we want to change the time or that threshold time, 5 seconds? If you just open the help pressing F1 on this QVERIFY, you can see here we have QTry-verify with timeout. Here we can, in addition to condition, we can provide a timeout, and it should be in milliseconds. So we can also set the timeout, and we have the same try method for QCOMPARE, QTry compare, and also we have QTry-verify too with timeout, different implementation for QCOMPARE and QVERIFY. So you can make use of QTry-compare also for asynchronous calls. For example, you're waiting for your network socket to be connected. So you can use QTry-compare, something like this. Let me bring it from the help. And imagine that we have a socket here. You compare socket data state with the connected data state. This is the way that we can check asynchronously for our socket to get connected. And this is the try version of our macros. Let's see what we have. The next macro, or the next concept that we are going to talk about, is failure expectation. Well, sometimes because of some bugs or some criteria, we expect some tests to be failed. So we will tell the QTest framework this test will be failed and it's under control. And also we can attach some data or some messages or some bug numbers to that one for more clarification, and then just bypass the code there. So how to do this and what's it good for? It's good for our CI pipeline. So when the test fails, we can say, okay, it's under control. Do not pay attention to this one and continue. I know this has some problem and we will work on this one. This may be sometimes good for some deadlines and some errors, some minor bugs that we have inside the codes. And let's see how it's working. So I'm going to create another method named test division inside our code. And let's create a method here, int. I know this is nothing, but I'm gonna use int for divide and accept again 2 parameters. And return 0. We are inside the ready state, and here I'm gonna create a method named calc and QCompare calc. Oops. That's divide. For example, 10 by 2, it should be equal to 5, but right now it's we're in the ready state, and I'm gonna just return, for example, a slash b plus 1. So something 1. I'm gonna return something 1, and if we run the test, we will be fail. Okay. Oh, we get to so compared values are not same inside the calc.divide. We just expect 5, but we expected 5, but the output is 6, so it's okay. And also I'm gonna comment this one, this lengthy operation. It's time-consuming task. I don't need to have this one. So here I'm gonna say Q expect fail, and the first parameter is somehow a data tag file. We just pass an empty string, and I'm gonna here say it's related to a known bug. For example, the bug number is 123, and continue. What does this continue parameter do for us? So first of all, let's see the result and then talk about this third parameter. I run the application. So here, as you can see, here we have XFAIL, test calculator, test division, known bug. This is the failure location. So again, test division passed under some circumstances, and that is the circumstances. And then we have 6 passed test. So, and what if I just return 5 here? Run the application. So it says XPASS. It says return true unexpectedly. So this is somehow, again, tell us some information that this code run true by chance. We don't know why. So check it, because we marked it as a buggy operation. So if you have all, again, an unexpected true here, the QEXPECT FAIL will inform us. So this is the way that it works on both fails and pass. And what does this continue mean? Imagine I'm gonna comment this one, and I am going to add two macros here, or two tests here, first for divide and the second for subtraction. I said we need to make the code simple, and every test case should cover just one operation, but here it's just for a test. Let's run it again. So we have passed this test division and nothing happened. And what if I just use this one and the mode continue? It says QEXPECT FAIL will cover next, just one next QCOMPARE or QVERIFY. And if after that something again went wrong, it's not gonna handle that one. So imagine here, I'm gonna make it F5. It should show us XPASS and run the code. So as you can see here, again, we have that XPASS, test division, return true unexpectedly, and again, pass it, the cleanup will be passed. So total, we have one failed here. So this time, because we have an unexpected true, just a QTest framework mark this test division as a failure. So what if I just make it false and run the application? Here, because we have an XFAIL, then this will be also run. So test division will be passed because we have a failure location, we have an XFAIL under control. Okay, so and this is the application of continue. When we use continue, we said, okay, after this, continue the execution of the test function. So what does it mean? I'm going to change this one also to 7 and run the test application. Wait. So here, as you can see, we have an XFAIL, and then again we are failed for real in calc.sum, return false, and so we have one failed operation here. Now, if I change this one to abort, we have continue and abort, I think. Yeah. This time it says, okay, after handling the QCompare or verify, after this expect fail, do not continue the execution of the code, just return. So I'm going to run the test and let's see the result. So as you can see, this time again, the test division passed because using this flag, we are not going to run this QVERIFY after handling this one in using QEXPECT FAIL micro. So this is the way that abort and continue works. And the last micro that we're going to talk about is QFAIL. QFAIL is another useful assertion in QTest. So it somehow behaves differently from QVERIFY and QCOMPARE, and it will unconditionally fails the current test function. It's somehow like saying, stop here, this state failed no matter what. And also we can provide a failure message to tell the user about what's going on there. And most of the time it's used for unimplemented actions or operations. For example, we don't have any multiply application, so I'm going to say test mode. And here we can directly use QFAIL and not implemented yet. So this test will be failed because we don't have any multiply operation. So what if I run the application? So we can say we failed. Test mode not implemented yet. What it says, yes, yet. Change it yet. And we have one failed operation. And then if we implement the mode, we can come here and remove this line. And also, we can handle unexpected situations. For example, here inside the division, let me test division 2. I'm going to say always I'm looking for division by 0. It should be returned 0, nothing else, not -1, not throwing an exception. It should return 0. So I'm going to say calculator, give me a calc instance. Then we can say if calc, I'm not going to use QCompare or QVERIFY. If it divide 1 and 10 and 0, it's something not equal to 0, then do not continue anything. You fail. Division by 0 should be not should not handled correctly. So let's get into divide. Right now we are inside the red state because we are not handle. Oops, let's run this. Run it again. So as you can see, null not implemented and application crashed because of this test division 2. So I'm going to say if b it's equal to 0, then return 0. I don't know why I run the application. Let's run it again. And as you can see, 7 passed and just 1 failed. And test division 2 all passed here. And if I just return, for example, I want to do some refactoring code and return -1, maybe, and run the test again, it says, again, we have a failure here. Division by 0 not handled correctly, and this is where it happened with this QFAIL. So this is the different micros that we can use to handle our test assertion in QTest framework. I hope you enjoyed. Till next session and cover more advanced topic in QTest framework. Goodbye.